Hey everybody, this is Larry. This is day 10th of the December Leetcode Day Challenge. Hit the like button, subscribe, and join me on Discord. Let me know what you think about today's poem. Today I'm a little bit low, so a little bit late. So I am going to skip the penguin things for now. But yeah, hit the like button, subscribe button, and if you want to see more penguins, let me know in the comments. I have so many penguins videos because I don't know, how can you get enough? So yeah, let me know in the comments before this becomes a penguin channel. Anyway, let's take a look at today's problem though. Hope everyone's having a great day. Yeah, let's go. 3577, count the numbers of computer unlocking permutations. You're given an array of complexity of length n. The n-locked computers 0 to n-1, each with a unique password. The password of the computer I has a complexity sub I. The password of the computer label 0 is already decrypted and serves as the root. All the other computers must be unlocked using it or other previous unlocked computers. By the way, if you think about this, that means that you already have a dependency tree, right? Maybe. So that's what I'm thinking about when I read these out loud, just to kind of give you a little bit of hint. I'm only thinking about the dependency tree, maybe may or may not be a DAG depending on the problem, and also already thinking about what's it called, topological sort algorithms, right? Sometimes I know what I want to do, I just don't always remember the name for them quite quickly. Anyway, okay, so then now we go, you can decrypt the password for computer I using password for computer J, where J is any integer less than I with a lower complexity. Okay, that's a little bit awkward, but that just adds an extra thing to the edge that we talked about with the thing. To decrypt the password for computer I, you must have already unlocked the computer J such that J is less than I, and complexity sub J is less than complexity of I. Okay. J is... What's the difference between this statement and this statement? J is any... Okay, so you can do it, and you need this, I guess. Maybe it's like a if and only if thing, but it's still a little bit awkward that they break it into two. Okay, find a number of permutations that... that's a little bit of wrinkle. We have a mod thing. Right? Okay. Man, I don't like sitting in this thing. Or maybe I just have bad posture when I do, because I feel like I have like some shoulder issues when I sit like this. Anyway, okay. Find the number of permutations that represent a valid order in which computers can be unlocked, starting from computer 0, which initially unlocked 1. Okay, I mean, I think this is a... Alright, I guess we'll look at the constraint real quick. N is 10 to the 5th, huh? Yeah, I mean, I think this is just count the number of what you might call it, right? Topological sorts, which has a lot of basis. Am I misreading this one? It sounds so weird. This one's a little weird. Okay, let me double. Okay. So going from left to right, it is saying that, wait. Yeah, I need to turn on lazy. Okay, I think this is, okay. So all the thing that I try to say about, what you call topological sort, I mean, technically it's true, but it seems like this one is very particular, right? And what I mean by that is that the computer with label 0 is already decrypted, and you have to unlock other stuff with it, right? But the computer with the label 0, you can only unlock... So 0 has to be the first element, I think, right? Because... Is that true? Depending on how they maybe it's already unlocked, so maybe that's not the first element, but it's either the first element or where it includes 0, or it's not, because you could say that it already includes everything, right? Or 0 is not unlocked because it already started unlocked, but then but as a result, that means that you will never use anything else other than 0, right? Is that true? Well, basically because the idea here is that you have a label 0 computer with some complexity, so then you unlock another computer that in theory unlocks other stuff, right? But that's not true, right? It's not it is a dependency thing, but in this case, the transitive property applies, right? Meaning that if A unlocks B and B unlocks C, then A unlocks C, right? Then as a result, you can say that for everybody. This is kind of true, but I think the other, then that means that if the computer label 0 has, I think that's true, right? It has to be strictly greater than, I suppose. That's what, okay. So, this actually is a little bit of hint as well, which I didn't consider. Maybe I would have if I get to it, which is the equalness, because it's strictly greater than, then there's no like tie-breaking things, right? Like in another world, you could say, okay, well, if two computers have the same complexity, then there is some tie-breaking things. And here, technically, there is, but not just by that, right? In fact, it just means that if you have n computers, the first one is whatever, then it's just n minus 1 factorial, right? Is this one of those weird problems? Oh, jeez. It's n minus 1 factorial because all of them can be chosen at any time, because you never care about which one to unlock, because you're always just using label 0 anyway. I think that's right. And then there's, of course, the impossible case where if you cannot unlock all of them, then by definition, you can't go smaller. So if you cannot unlock even one of them, then it's 0, right? I think that's right. Maybe, I don't know. It's a weird problem. It's one of those, like, I don't know. It's just weird, right? So maybe we'll see, right? So complexity of 0, right? So for I in range of from 1 to n, if complexity is greater than equal to complexity of I, then we just return 0. Otherwise, we return factorial, right? So that's and it goes up to 10 to the 5th, so you have to do it in a slightly smart way. What am I like? And that's basically it, I think. That's give me a YOLO submit. Come on, let's go. Okay. Yeah, it does seem like one of those, I don't know. I don't know if it's a gotcha problem, because sometimes people say it like that. But it is like a, I don't know, it's a little weird. This is going to be linear time, right? Constant space. I don't really have much to say. I think that let's take a look at the hint. I don't know. Oh. Yeah, I guess that's the hint, but did I mess this up? How is this right? Because actually, I think honestly, I'm just dumb today anyway. I wrote this unintentionally to n minus 1. Okay, so I got really lucky and it works. But I said n factorial. I meant n minus 1 factorial. I said n minus 1 factorial, but I tried to implement n factorial, but I implemented n factorial incorrectly, and I implemented n minus 1 factorial, which is what I actually wanted to do anyway. So in a way, my two silly mistakes just cancel each other out, and I'm here for full disclosure because I don't need to look smart. In fact, I don't need to look stupid either, but I'm just full disclosure, full honesty here, right? Wow, that is sloppy. That is actually not great. But yeah, but I would say the problem solving part, I think we're okay. Maybe implementation I need to be better at these days. But yeah, that's it. That's all for this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.